Hello, good afternoon. Nice party yesterday. Well done, RIPE NCC. My name is Zorz. I come from Slovenia. I work for Internet Society. But this presentation is something that, so as I mentioned yesterday, I founded the Go6 Institute. That's a not-for-profit organization to promote IPv6 in my country. And as a part of Go6, we built a Go6lab. That's a 3 racks of equipment, lots of stuff, 3 uplinks, full BGP v4, v6 tables, and so on. And we are testing lots of IPv6 stuff in our lab. But then, IPv6 became a little boring because, it's done, everybody's deploying it, it's well seasoned and so on. So I decided to go for experimenting with DNSSEC and DANE, basically just because I was curious and because I could. First, the acknowledgement. I would like to thank ISOC to let me spend some of my working time in Go6lab and test all these new exciting protocols and mechanisms. Because if I talk to you about these new protocols and new mechanisms on the internet, I don't just go and read about them and then talk to you. I go and test them. I implement them and run them. So I more profoundly understand how all this is done. So how did it all started? There's a story behind. Matthijs, back then he was working for NLNet Labs. He asked me at one IETF, why is Go6.SI not DNSSEC signed? And I said, oh, it's not signed because I don't want to go into all that academic complex stuff in understanding DNSSEC. I don't have time, I don't have patience for this. And I said, can you please write for me a very deployment-oriented document that says, okay, you need to install, a Linux box, you need to install OpenDNSSEC, these are the files that you need to edit, and this is how you add the domain, and this is how you sign the domain, and this is how you publish the DS key, and be done with it. And actually, he did it. So what I used was PowerDNS server as a hidden primary. Then I used OpenDNX platform, OpenDNSSEC platform for signing domains. And then there are bind9 DNS servers as a secondaries to serve the signed zones. Virtualization was Proxmox 3.4. And OS templates at the Proxmox were Fedora 20 and CentOS 6 and 7. Why Fedora? Because OpenDNSSEC package is well maintained on Fedora and pretty up to date. So I decided to go as a bump in a wire. Why? Because I still have my hidden primary that contains the non-signed zone, and then it's OpenDNSSEC in the middle, and then the public the primary. So in case anything goes wrong, I can go back to the old state anytime I want. That was fairly easy, works very well. So how many of you signed your zones with DNSSEC? Show of hands. The usual suspects. Again, okay. Believe me, I needed the whooping 17 minutes to set up the whole thing and sign my zones. 17 minutes. There is no reason why you can't do it. And if you just follow this PDF, there is a link. It's fairly easy. It's like four pages of instructions how to go through the process. After a year, so that was now in September. Matthijs also wrote the KSK rollover guidelines for me, so I did my first KSK rollover, and my domains did not fall off the internet. So this was good. Well done. Okay, then I got my domains signed, and everything is working. Now what? Then I got bored. I was like, what can I do now with signed domains? And then I said, okay, let's do the DANE experiment. I was reading a lot about this DANE thing. So who here knows about DANE? The usual suspects again. Okay. I will describe later the DANE and how it works. It's basically the DNS authenticated name entities. It is where you publish your key, or just the hash of the key in the DNS system from your TLS certificate, being on a website or email server. So you can then check for the destination when the TLS certificate is presented to you that you want to start encrypting. You can check in DNS if the hash matches. So I decided to go for testing with email, and I used Postfix server. So you need to have higher than 2.11, the Postfix. So I just decided to go for 3.0.1 and just be done with it. It works fine. It's perfectly fine. So first thing to do with DANE is you need to create a TLSA record in your zone. And as you see here, so that's my mail server, mx.go6lab.si, and here is basically the port and the protocol. So here is port 25 over TCP, that means mail, for the machine mx.go6lab.si. Here is the hash of my certificate. There are really good guidelines and instructions how to create TLSA records, and it's very easy. You go on your mail server, you figure out your hash, and you put it in your DNS. We have lots of resources about DANE at the Internet Society, a shameless plug. And that was also how did I start testing. Basically, I sent an email to Benno Overlander. He is now the CEO of NLNet Labs. I know that they implemented DANE, and I just wanted to see if my server is verifying his server, and then I asked him in the email, I said, okay, respond me back, and then go to the log files and see if your server verified my server, and it worked. Okay, very briefly, how DANE works. So, when you try to send an email from your MTA to this one presents back start TLS and presents back the TLS certificate. And then you ask your resolver about the TLSA record. So is there a TLSA record for underscore 25 TCP and this destination? And if this DNS presents back the TLSA, then DNSSEC check is done and validation, and then this one says, okay, those two hashes match, so this is really the destination that I want to send email to, and then the start TLS, then the TLS session is established. So I was able to verify TLS cert to T2. That's one of our ISPs in Slovenia, the second largest one. Then NLNet Labs and some others. So here is a copy paste from the log files that you see that verified TLS connection was established. So if you implement DANE and you start validating remotely, then you see validated TLS, verified TLS connection. That means that the destination was actually verified by DANE. Yeah, okay. So this is my Postfix config. If you want to start deploying it at your network, at your mail server, this is what you have to do to actually make it work. It's fairly easy. Okay. Then I got bored again. Because DANE was working, I was verifying people, people was verifying me. Then I say, okay, let's check if you malform the TLSA record. And I published a TLSA record with a bad hash. I just changed one character. And of course, Postfix failed to verify it and actually refused to send a message. And this is good behavior, because if I say I am the mail server that you would like to talk to, and if the hash is not the same in the DNS, then it's the hash from the TLS certificate, then this is clearly man-in-the-middle attack, and I'm not sending email to you. So, well done. And then I got bored again, really. I was like thinking, okay, am I alone in this world? Just me and Benno and some other guys? Or is there more people using DANE, right? So I fetched the 1 million Alexa domains, top 1 million Alexa domains, and I created the mails that were sent to email address that should never be delivered, like test-DNSSEC-DANE at each domain. I built a script. This ran for 15 days or so, or something like this, to check all the things. And then here are the results. Out of 1 million domains, 992,000 and something of them had MX record and mail server, actually. And this was a big surprise for me. Nearly 70% of all attempted SMTP sessions were encrypted with TLS. How cool is that? 70% of sessions were encrypted. I was like, wow. Of any kind, of course. Trusted, untrusted, anonymous, or verified. But 70%? Dear NSA, you are not reading our emails anymore. And also next result is also surprising to me. Majority of TLS connections, 60%, were established with a trusted certificate. That means these people paid money to some CA to have a valid signed certificate for their mail server. And 1,382 connections, they just failed with cannot start TLS handshake failure. These people will never get an email from me, believe me. Okay, if we dig a bit deeper into the results, so the TLS established connection ratios are, so there is 410,000 trusted certificates. There is 167,000 untrusted, 109 anonymous. That means just the certificate is created, but it's not signed. And verified, 128. That means DANE is alive. People is using DANE. 128. I was surprised. I saw that the number would be like 4 or 6. 128. Hooray! Maybe we can increase it. So when you go home, implement DANE, so we will be able to change the numbers. But yeah, 128. I'm not alone in this universe. That's a good thing, right? And this is the mail distribution. Okay, Google.com has 125,000 domains handled, and TLS state is trusted. Then we have this Yandex.ru. I don't know where this people is from. 9,268, and they have trusted certificate. For example, QQ.com, they have no TLS. How can you have a server without the TLS? Come on, right? OVH.net is most trusted with redirect servers having no TLS at all, so it's a bit of a mess. Then we have Yeah, so this is the mail distribution that we saw in the top 1 million domains. So DNSSEC or DANE, so the big mail servers that you saw and their domains, none of them is DNSSEC signed, and that means no DANE for them possible. So if you work for one of these big guys, please sign your domain and introduce the TLSA record. And then I got bored again. I wanted to see in how many ways DANE fails. So, of course, wrong certificate hash in TLSA refuses to send email. But then, what if the domain where MX record resides is not DNSSEC signed? So, can't trust the data in MX, so no verification. What if TLSA record published in a non-DNSSEC signed zone? So, you can't trust the data in TLSA, so no verification. Let's test. So, Go6lab zone is signed. So it's mx.go6lab, and then for the purpose of better understanding, I use the zones sign.si and not sign.si. So if the domain sign.si is signed and mx points to mx.go6lab, then things work. But domain not sign.si and mx points to mx.go6lab.si, and if you send the email to jan@notsign.si, what happens? Should it verify the destination or not? It doesn't verify, despite the fact that the destination, A record and quad A record are DNSSEC signed, and there is a TLSA record. It doesn't trust the MX record because it's in the non-signed zone, and the DANE verification process in Postfix, it just exits. It does not even start the DANE verification. So what you get, so if you send the email to jan@sign.si, you get verified, and if you send email to not signed, you get anonymous. That means the DANE verification did not even take place. Okay. And then I got bored again. And I said, okay, what if I publish TLSA record in a non-signed zone? It doesn't work. It doesn't work. DANE verification needs completely established chain of trust in a DNS tree. Completely established chain of trust. So if you publish TLSA in not signed zone, it will not work. It does not make sense, right? Okay. So next step was, what if I put in the malformed TLSA record in a non-signed zone? Will it prevent the man-in-the-middle attack? It does not, because the DANE verification does not verify if the TLSA record is not published in a signed zone. So despite the fact that we have a TLSA record with different information that TLS certificate from the mail server is presented, it does not prevent the attack. So you need a completely established chain of trust. Conclusions. 70% of email can be encrypted. It's a very low number of DNSSEC signed domains servers, and even lower number of DANE TLSA verified servers and connections. And I was surprised how easy it is. It's really, really easy. You just go and do it, basically. You can download this presentation from the website. There are links inside. DNSSEC signing is easy, DANE is easy, and I see no reason why we would not do it. And I believe that your CCTLD is DNSSEC signed, right? Dmitry? Is it signed? Okay, and how many DNSSECs? Okay, I missed it. Okay. Okay. Yeah. So there are some domains signed, but you need to probably. Will you go to the mic and repeat that? So just to finish my conclusions, DANE verification fails if there is no chain of trust, and actually DANE is easy. Do it.
So actually, I would have a suggestion for you just to finish. Like this 1 million emails, I think it's a great idea. I mean, everybody loves email, right? I mean, you know, it's like, you just don't advertise anything. So why don't we do kind of this adoption statistics? Maybe we can talk about it later. And basically, I mean, we only have that many, but some other TLDs have more, because I'm in TLD world more than in this IP world. And so basically, when I signed this private bank, well, it's privat24.ua, it's their online banking system. I discovered not just they have a PV6, but they have a V6, they have DNSSEC, and they do have DANE record, but I didn't try to send email. So not just for their benefit, but I guess for benefit of others, I guess I can provide you with a list of DNSSEC signed domains, and we can try it.
Yeah,
I hope these 10 people would not mind to receive one bounced email in their logs.
Well, I have this whole testing.
Just because they have a tool, right?
I have all this testing tool built, so I just feed them domains. So if I have a list of domains, send them to me. And
yeah, exactly. So let's do that, and we can make a little lightning talk about that in maybe Southeast Europe.
Okay. Thank you.
Hey, the question. Have you tested the usage of not so widespread, not so wide used algorithms of cryptography? So like elliptic curves or Russian standard ghost, like this.
No.
So I see here. Sorry. I see here the 2 points of failure. First, the unsupported algorithm in DNSSEC validation, and the second, unsupported algorithm in the TLS session. Have you tested it?
No.
Any expectations with this? Because ECDSA algorithm seems to be very popular in coming years.
Well, I can go back in the log file of that experiment and maybe extract it from there. But basically, what I wanted to test is if I'm alone in the world using DANE. That was my basic question, and the answer is no.
Finally, there is the water on the Mars.
Yeah.
Okay.
Did you ever try DANE for SSH connections? And if yes, which kind of software do you use? Maybe plugins or patched SSH, secure shell?
So what's the question about the web?
It's not a question about web, it's a question about DANE. It can be used to provide that we connect to exactly what this server we want, like for SSH, secure shell.
I did not test, but I will.
Is it work? Do you know?
I don't know. So there is Jaap, probably he has the answer.
Jaap Achhuis from NL Labs. There's actually the SSHFP record in DNS specifically for the SSH. So there's no need to do DANE. And this for that, because there's already, you can do it, but who cares? What DANE does is actually the verification between the servers. So locally, your mail is not encrypted. And there's actually some work on trying to get certified mail also per user, but that's protocol in development. But you have to to see what is protected and what not. So it's not, it's actually against people listening to your mail on the third parties, but not local.
Yeah, so this is the destination verification, not the path verification.
Right.
Okay?
It's working well. Any more? Otherwise, I think we have a special treat for you. If you like DANE, I think we do. All right, thanks, Jan.
Thank you very much.
Okay, Jan, but I ask you not to leave too far, because we have some time in this session, and we like to have a lightning talk sent us by Mr. Samorukov from Czech Republic. Unfortunately, he wasn't able to came here to speak about DANE, but then I'll deliver this lightning talk, and you can ask if you will have questions to Pan Samorukov. He's on online chat, and maybe you also continue discussion on DANE.
Yeah,
so.
absolutely.